For this Roomba project, I've finished giving the formal lectures that I'm feel like we need to do to get the background on it. So today we'll talk about a couple issues and then answer any questions or get to work on whatever you guys are having problems with. First thing, I was talking last time about getting the labels out of the file data, out of the file names, and I looked real quickly and I didn't see, but I did actually have, I wasn't going crazy. I remembered I had done something like this, giving you a little piece of code for that. But like what I've said in the submission guidelines is that, you know, I'm giving you both the Roomba 1 and the Roomba 2 image, and then you need to create your augmented data by rotating that 1 through 359 degrees and storing those images in a folder somewhere. Okay, so for example, here's what I have. Wonder if it'll look better if I make this small icons. No, or I mean preview. Oh, doesn't it? There we go. Oh, small icons, it doesn't put the picture. Medium icons does. Okay, so for example, here's my folder where the Roomba 1 images, I have them called train 1, and then an underscore, and then a number for, you know, that's 0 degrees, 1 degree, 2 degrees, etc. And so, you know, they rotate all around until I get down here to train 1. 359 degrees. Oh, look, I even did a 360. I wonder if I loaded that one in. But anyway, it shouldn't hurt, because if you have a 360 and a 0, they might not actually be exactly this. Well, they should be exactly the same image. They should be exactly the same image, but if you have labels of 0 and 360 as the angle, they're going to end up with the same sine and the same cosine. So you would just have the same image twice if you happen to do that, which shouldn't harm anything. You know, technically, it's being trained better for an angle of 0 than anything else. You know, that is sometimes an issue, that if you have, say you're doing a classification task, and you have 5 images that are not the thing, and you have 5,000 images that are the thing, the neural network is just going to learn, I can get a very good error easily by saying they all are the thing, because there's only 5 things that are not the thing, and the 5 out of 5,000 is going to give me a very high, very good error. Okay, so you do have to be a little bit careful of balancing things, especially when you're doing classes. But in regression, it's not as much of a problem as long as you don't have big gaps in your feature space where there's no training data. Okay, but if you repeat the same thing a couple times, that shouldn't really hurt so much. Then I have train 2, and so then that's the other image. That's the Roomba 2 image, and so then you can see I've got, and you can tell they're slightly different. I mean, look here. This one's not quite centered in the same way. It looks like the top of the green thing is closer to the edge of the image, that it's sort of shifted up or something. Maybe it's angled. Maybe the camera is not pointing straight down on it, that the camera is angled a little bit, because the Roomba seems centered in the image pretty much in the same way here, but obviously it's a little bit higher than that one. So you can see there are definitely some differences between those images from Roomba 1 and Roomba 2. And so then Roomba 2, the train 2 for Roomba 2 goes from 0 all the way up to 359 or 360 in this case. Okay, so this little block of code uses glob, and then it loads in all of the file names in this folder. Okay, all the file names, no matter what they are. There's a wildcard there as long as they're JPEGs. Okay, and then it loops through each of them, and it finds where in the image is where in the file name string, those are file strings, where is the underscore, and that's going to be the beginning of where the number is, and then where is the period, that's going to be where the end of the number is. Because when it's 0, it's just 1 character, and when it's 10, it's 2 characters, and when it's 100, it's 3 characters, so it's not necessarily a certain number of characters. Okay, and so then it's saying where the beginning and the end is, and I'm going to go ahead and slice that out, where I'm going to go one farther. I don't want to include the underscore. I want to go to the next character, so there's a +1, and then I'm going up to the end. Now you'll recall when you're slicing in NumPy that index number is not included. It's one less than that is the last one that's included, which is kind of weird. I still don't know why Python has done it that way. Okay, and so then I'm doing the ith file name, slicing out the part of it that has the number in it, and then I'm converting it to an integer because it's a string. And then printing out what the angle is, that's the integer for that, and just printing out the type of the angle just to show you that it is indeed an integer. Because if you just displayed without doing the int there, it would look like it was the number, but it would really be a string. So this little piece of code is helpful for you to be able to load that in, and then to go ahead and work on all the data. Okay, in your final Project04 last name.py file, I want you to go ahead and load in all of Roomba 2's files. So instead of having an asterisk here, in my case, I would write train2 star.jpg. And that would only load in the train2 ones and not the train1 ones. Okay? And then there is a requirement in the rubric for how well you do with the Roomba 2 images. And then when I evaluate it, I'm going to go ahead and change this path and the file name there to point to the test underscore numbers.jpg, so that I can then check and see how well it does on your test data. So all I'll need to do is just change this string here to not point to your Roomba 2 stuff in the training, but instead to my file in my folder where the test stuff is. Okay. So that's sort of how I would like you to handle the image files. And I do want you to include in your zip file, your folder with all of your training images so that I can see them. Okay? I mean, they're going to look exactly like this because, there's really all you're doing is just rotating 1 degree, 2 degree, 3 degree, 4 degree. So, it's, they should look exactly the same. Okay? So that was one thing I want to make sure we go over. I think I've pretty much talked about everything else now, about how we want to use the sine and the cosine as our two outputs to the neural network, and we want to do early stopping where we these 720 images, we want to set aside 20% of them to be in your validation set. Okay, and we're going to use early stopping to look at training and make sure we do early stopping if the validation error gets worse, the validation performance gets worse. We want to stop our training. I think there's all sorts of techniques of how you want to go about that. I mean, the concept is clear that even if the training error is decreasing, if the validation error is increasing, we want to stop training. I mean, so that concept is easy, but how do we get into the details of doing it? In this case, at least here, it looks nice and smooth, and it looks like the validation error is monotonically decreasing. It may or may not actually be, and especially here, you can see there are some little bumps and jumps in there. It doesn't just always go down. And it's even true in the training set that it doesn't always go down. It can jump around a little bit. So you don't just want to say, oh, well, was the validation error this time worse than last time, because you might be in a little bump. Okay, so you can work out whatever strategy you want to handle that. I think what I did is I stored a certain number of epochs back in the past. I stored the value for the validation error, and then I don't know, maybe it was 10 or 20 epochs or however many epochs in the past it was, and then I look, is the current validation error lower than that at some point in the past? And if it's higher, then I'll stop. and that way it allows me to have those 20 epochs for it to the noise to happen and it to at least trend downward over those 20 epochs. So I did something like that. You're welcome to use whatever strategy you want, but you definitely want to stop your training to before just don't let it be driven completely by the training set. Okay. Then, of course, we want to look at all of the different numbers of hidden nodes and test that out and see how good of performance do we get for different numbers of hidden nodes. And you definitely want to go high enough that you can see that it's not going to decrease at higher number of nodes. And for each number of hidden nodes, you want to make sure you run multiple times. Of course, more is better. I think I did 10. I think there's 10 of those red circles for every value of the H. Okay, and I think in the end what I did is, as it was going through all of that, if whichever of these red circles was the smallest, I went ahead and saved that one, and that's the one that I used. Okay, and this is it doesn't say in the figure, but here in the heading here, I say that that is the validation set error, okay, or the mean absolute error in degrees for the validation set. You want to be basing all these things. How well is it doing the validation set? Because that's not being used directly for training. Okay. And then in the end, you want to show what is the error and angle for whatever your ground truth angle is. And this would be for Roomba 2. You would set up your file to go ahead and produce an image figure like this for Roomba 2. And then when I go ahead and change the path to instead look at the test data instead of Roomba 2, then I'll get the updated one for the test stuff. Okay? Okay, so what challenges are you guys facing so far with what you're working on?
Starting.
Your challenge is getting started? Okay. Anybody else? So, I mean, yeah.
Crop your images automatically there.
So the way I did that is that in both the question is about cropping the images. In both Roomba 1 and Roomba 2, even though they have different resolutions, I have made it so that the Roomba itself is in the center 200 by 200 pixels. Okay? So unless I've done something terribly wrong, that's what I think, I'm pretty sure I did. And so you're going to take your image and you're going to rotate it from the center of the image and get it to rotate, and then that will have done the whole image. Right. But then you're only going to take the center 200 by 200 pixels, and the Roomba should be within those. Okay, so that's how I've cropped it, by me already ensuring that the size of Roomba 1 and Roomba 2 make it so that it's within 200 by 200 pixels in the center of the image.
Can you use CD resize for that?
You won't need to. You won't need to resize it. You just go ahead and take the middle, those 200 by 200. Okay? And so these things should be 200 by 200. They should be 200 by 200 pixels, which they are. So you don't need to do any resizing, because you just go ahead and slice out the 200 by 200 that are in the middle. So I've done some of the sort of the pre-processing of getting them in a good format for you, that you just need to do the rotations. And I did that because if I only gave you the 200 by 200 image and you rotated, there would be more of this black stuff in there. If I only did the 200 by 200, you'd have a lot more black. But because I've given you more around the Roomba, if you rotate the whole image, you don't get new black from than whatever is already in the image itself. So that's the reason why I gave you the bigger than the 200 by 200, so that you'll have less of the black around the outside edges. And I think, isn't it? It's Roomba 2 that has the black at all. Let me go ahead and confirm that. Yeah. Oh, can't do that. Can't show you Roomba test now, can I? So that's Roomba 1, and that's Roomba 2. You see there's a lot more of the black right around where Roomba, on Roomba 2. So and I think with Roomba 1, you rotate that, you won't get any black in any of them, but in Roomba 2 you do. So they're slightly different. Especially, the green is darker in one than in the other, and it does look like in one situation the camera is not directly overhead, so it's angled a little bit, and that's sort of the main difference between the two. Other questions? All right, so I guess we'll just go ahead and I'll stop the recording.